Hello and welcome back to this course, covering the exam topics for the JNCIS ENT certification. In this section of the course, we're reviewing OSPF, where we will review OSPF concepts, configurations, and troubleshooting in Junos. In this lesson, we're reviewing two important roles nodes may play in an OSPF deployment if elected. These are the designated router and backup designated router. To understand the reason why these node roles exist, we need to take a trip back to the year 1991, when OSPF version 2 was released. OSPF v2 is the common OSPF deployment version we see still today. This was developed and released 4 years before the 100 megabit fast Ethernet standard was released in 1995. This means the average speed of links we saw in the environments where OSPF would be deployed is 10 megabits or slower, where every kilobit of data throughput mattered. Because of this, limiting unnecessary network control traffic from our dynamic routing protocol is very important to free up as much space of our network resources as possible for user data. This is where the DR and BDR come in. These roles allow for the reliable distribution of routing information without unnecessary network traffic from all the LSA flooding and database synchronizations. So, let's take a look at the details of the DR and BDR role, how they are elected, and what configuration options we as the network administrators have for influencing the election. On a broadcast domain, OSPF-speaking routers will only synchronize their databases and for full adjacencies with the DR and BDR on the segment. As we now understand, OSPF was developed in a time when network bandwidth was at a premium. Although we didn't have the rich video streaming and graphics available over the network like we do today, the available network bandwidth was still small in comparison to the demand. The DR and BDR are elected roles on the broadcast segment and are the sources of truth for the segment. When the changes in the OSPF topology occur and updates are flooded through the network, only the DR and BDR will flood the LSAs to the other nodes on the broadcast segment. This function is primarily achieved through the situation described in the diagram here. Nodes on a broadcast segment will only form full adjacencies with the DR and BDR on the segment, and will only maintain two-way neighbor relationships with all other nodes on the segment. Additionally, the DR and BDR will be the only nodes to advertise the network LSA for the broadcast segment to the rest of the OSPF system. This is often described as the DR and BDR representing the segment as a pseudonode. Since we've mentioned a few times about the DR and BDR roles being elected positions within the OSPF protocol, let's review that election process in more detail. The router on the segment with the highest priority value configured will be elected as the DR. The second highest will be elected as the BDR. If all priority values are the same among routers in the segment, then the router ID will be used as the tiebreaker, with the highest RID winning the election. Same would go if a single router were configured with a higher priority, but the remaining routers were all the same priority. The highest priority router would become the DR, and the highest RID would then become the BDR. The DR-BDR election process only occurs for 40 seconds from the time the OSPF process starts. At the conclusion of 40 seconds, if another router comes online with a higher priority or RID, it will not preempt the existing DR or BDR. During the time that the election is occurring, the designated router and backup designated router fields in the hello packet shown here are populated with zeros, indicating an election has not yet occurred. Once the election has completed, then the fields are populated with the router IDs of the respectively elected DR and BDR. In order for the DR or BDR to be replaced on a segment, the existing adjacency with the DR or BDR must go down for the nodes on the broadcast segment to allow the next router to become the DR or BDR. When the DR goes down, the BDR will assume the position of DR. It doesn't matter if there's another router in the segment with a better priority. The BDR was already elected as the backup and will become the DR. However, with the DR down and BDR taking its place, the most preferred router will then take the place of the BDR role. Because of this difficulty in changing this attribute, it's important to select your preferred DR and BDR ahead of time, preferably to be the most reliable and resilient routers on the segment. Now, let's see how we configure the interface priority to influence the DR and BDR election process. The default router priority in Junos is 128. The priority value is a configurable value ranging from 0 to 255. This is because the router priority field in the OSPF hello packet is an 8-bit field, and therefore can be expressed as a decimal number from 0 to 255. In OSPF, a higher priority value is more preferred and will win the election. It's common for the preferred DR to have the priority value of 255 configured, and the preferred BDR to have the priority value of 254 configured. As we see in our configuration snippet here, the priority value is configured under the interface of the OSPF area configuration. Below, we have the valid completion for the command, which is looking for a decimal ranging from 0 to 255. And that's all that's needed to influence the DR and BDR election process. This is not a required configuration in OSPF, as the router priority defaults to 128, and therefore the DR and BDR election would fall to the highest router ID and second highest router ID seen on the segment during the election period, if no explicit configuration is made to adjust the priority value for any of the connected router interfaces on the segment. I appreciate you working through the details of the designated router and backup designated router roles and election process with me. I hope that this lesson has been informative for you, and I would like to thank you for viewing.